Or did your machine lock again?
Maybe.
Yep. Ubuntu is awesome.
Did you get my email?
You sent me an email?
Yeah, Sunday.
Kill Ken. Apparently I'm not getting my emails.
Well, I don't know if it sent it, because it sent it to me, and I didn't know if it sent it to you.
That's what it did to me too.
If it sent it back, you probably put my address in wrong. I'm gonna write down my corporate email. It's shorter. Sorry guys, just a second.
I'll just draw everything on the board.
You're just going to draw what Elasticsearch looks like really quick?
Yeah. Really quick.
Got 7 minutes. I can get this back.
Can recover the operating system.
Demo guides.
And Chessman learning the different operating systems.
He doesn't know how to use that, man. What's he using? Is he using, are you using LTS? That's always my rebuttal when people complain. You're not using LTS.
Do I need to get my laptop? I don't have the live demo on it, but I
good.
can do this way. Sorry.
No problem.
If not, it's okay. I'll just draw it on the board. We're good. Live demo is going to be a little difficult, but I can just draw everything on the board. It'll be all good.
I think I need to reduce my resolution before I plug the monitor.
Yeah, we talked about that.
Like, didn't you? Isn't that
About
the lesson
duplicating
learned?
displays and whether or not you should have that enabled.
I wasn't sure if that was a problem. Might be.
Somehow it's very hard to go down from 3200 by 2400 to 600 by 800. Still have 5 minutes.
So you guys gonna be in Initech next week?
I may or may not. I've registered to go, but
Isn't next Tuesday, right?
yeah.
What good are you, Cameron?
Not much.
What's up, Peter?
What's he do well?
Message boards and discussion.
I was going to tell you, you can probably sit in one of our chairs.
If you don't like writing papers, I wouldn't suggest it.
Fingers crossed.
I think the key thing is to try to get under your skin.
And you're not mirroring.
I'm going to be taking any application classes.
And you're not going to mirror.
Yes.
It just didn't crash, so it was step in the right direction.
Joseph Campbell. American Post.
You are lucky.
Everybody else with that.
Drum roll. It surprisingly worked earlier.
Do you want to pull up the sway?
Yeah. But since you're mirroring, I don't know how we're going to do that.
I can unplug for a second.
Oh, I'm using my laptop?
Whatever you want to do.
That's okay. Just start this up. We have a few more minutes. You can pull up the screen on your computer.
Yeah, I'm just getting everything set up.
Hello.
Just fine. I have to go to an advisory committee meeting tonight, so I can't be here for this, so I told them to record it. We would have stayed and saw it down at IWS, but somebody wouldn't let us stay
blame
for
it
the
on
third
me.
session. I'm really gonna go back. So we couldn't see it then, so. All right, well, I gotta run to my meeting, so I appreciate you coming and, you didn't buy the pizza, Vic? Jeez.
I'm a college student. I'm broke. What are you talking about? Pretty sad when you can't afford CCs for 20 people.
Yeah, it's almost done actually.
What's up, buddy? No problem, man.
Still 30 seconds, Chad.
It's okay, we're still gotta figure out the network connectivity. See if we can pull up the swing.
Vic, do we have a sign-up sheet for this one?
I sent you an email. You didn't get it.
Alright,
I'll check.
your turn.
We'll try to figure out the network. Get on there.
It's just an open guess, so you should be able to get to it.
Says it's open.
Well, there'll be a portal page.
Somebody. I went to bed about 4:30.
Try to get like Google.
Google does us help.
No, I gotta go to class.
Didn't see anything.
One's health, one's security commerce. I'm doing operating systems and so I actually have 3 cyber classes. That's it. Next semester.
Yeah.
Since I'm doing operating system out of the way. Security commerce I'm taking in the second 8 weeks. So my first 8 weeks is like, hey, I think we'll do nothing. I took OS.
Might not have network coverage for it, which is fine.
I signed up and pen testing. I have what is it, mobile device and cryptography. All in the same. All in the same semester. But they're the last classes I'm going to go. So I kind of have to take them. I'll graduate in May with all of our certifications, but I had to get security. Yeah, last spring I took
It's okay, there's always a whiteboard.
You want to solve the problem?
I'm just gonna draw the whiteboard within the frame.
For a second, the pixels from the projector stressed me that it might actually be a whiteboard and it's one of those smart boards. Whereas I've never actually drawn on a smart board, I have seen a big black blot in the middle of it with a big sign under it saying, "Please don't draw on the smart board."
Now they have whiteboard smart boards, so hey.
How do you know? How can you tell?
This way doesn't use any weird ports.
You don't, so you're scared.
No,
I
it's
guess
all,
you can take a marker and send
Oh, there it is.
it leaves a mark on your hand.
That's how I do it.
There it is.
Screw it.
You wouldn't need a whole weight.
Oh, you broke it.
Apparently I did break it. Nope. Okay. Important lesson. Technology, you have to be very conservative. If you're trying to be fancy like this, it's going to fail you. So,
Pretty much.
hello.
Hola.
We are going to try to talk to you about elk hunting. I'm Paul PC, I work for Devon, I'm a security architect. I love motorcycles, I love working on motorcycles. I'm terrible at working on motorcycles, so my motorcycle is often broken because I work on it. And this is Chad.
Hi, I'm Chad, I also work at Devon. Spent a lot of time doing web development background stuff. Previously I worked at OU and recently joined Devon this last January. And I like to play around on motorcycles too. I'm not sure why Paul put a picture of a boat up there, but whatever.
Because I like boats too.
Boats are like motorcycles. It's always the same vehicle.
So, before I start, I want to kind of move away from this a little bit. Who here knows anything about incident response?
Taking classes.
Awesome. How about logging? Yay. Anybody heard of Elasticsearch? Splunk?
Yes, actually.
Awesome. Cool. So we started doing this about a couple of years ago. We have fancy logging systems. We have an instant response procedure in place, but we keep going into the problem over and over again. Even if we have really fancy antivirus, even if we have a fancy logging system and a web filter and intrusion prevention, we still get alerts on the machines. And the problem with getting those alerts on the machine is we don't know 100% whether or not the machine is compromised, right? So McAfee or Norton tells you that it deleted whatever virus, but can you really trust it? Because antivirus, the efficiency rate for antivirus is, let's say, 20%, or if you want to be really generous, 40%. So out of all, let's call them commodity malware that you can find there, Zeus or some banking Trojan that you find out there in the wild, antivirus is likely to catch about 40% of it. For anything that your adversary actually wants to throw at you, anything advanced, it's going to be close to 0. Because antivirus is in a terrible shape right now because it's looking for patterns. And it's very, very easy for the bad guys to change up the patterns just enough for antivirus to not catch it, or at least to have a few days, weeks, months of lead time before antivirus will catch those malware. So we have all the fancy tools. We're still not sure whether or not we clean up the computers. Oh, it's going to work. Yes. And so then we thought maybe we can buy more tools, which is really cool. We have the money, we have the people to implement it, but unfortunately the business tells us that computers need to run actually business stuff and not just security tools on them. So we can't really add 5 more agents on it and be a little more secure. We have to figure out a different way to do it. So the paradigm we're playing with right now, instead of having an agent on all of the machines to do instant response, we're doing a dissolvable agent to where we deploy scripts to these infected machines and gather a lot of telemetry from the infected machines. Once we get that telemetry centrally, then we can look to see whether or not there is, let's see if I have something here, maybe. Yes. We'll talk about it later. Whether or not there's weird looking processes or weird looking executables on the machine itself. If we find those, then we can go back and actually start cleaning up. So how do we do it? We have a kind of a two-step process. We need a back end to store all the telemetry information and a front end. So there's multiple ways to do it. We looked around at Splunk, but Splunk is expensive. We started to experiment a little bit with Elasticsearch, Logstash, Kibana. So what is Elasticsearch, Logstash, Kibana? Elasticsearch is a document repository. I want to think of it as a database, but it's not really a database. And so you have a lot of things looking like this. A key value pair, so kind of like a hashed array. And you can put a lot of those arrays into Elasticsearch. But then Elasticsearch gives you the opportunity to do a lot of very fast indexing for the data, as well as really quick search. Because it is distributed across multiple nodes, it's very easy to add other nodes to it, and so performance can be a factor of just very cheap hardware with Elasticsearch installed on it, instead of, like, let's say MySQL or Postgres. To get additional performance from your cluster, you'd have to add solid-state drives, a lot of memory, a lot of very expensive kind of hardware. Elasticsearch and any technology like this, you can just add more cheap servers to the cluster. You get better performance. Overall, it's pretty cheap. So we have Elasticsearch as our document repository. We can put all of our data into Elasticsearch. How do we put the data in there? That's where the L in the ELK comes in place. Logstash is an information broker. So you send syslog, you send logs to Elasticsearch, and before they get into the database, they have to be parsed a little bit and they have to be modified. So Logstash takes the network information, turns it into the key value pair storage that we were talking about, and then sends it over to Elasticsearch. It's really, really easy to use. Sorry?
I'm sorry, I'm reading the code.
Okay. If you have questions or comments or want to call BS on what I'm talking about, please just interject. Before we looked at Logstash, I had a 300-line Python script to do what I'm doing with a 15-line Logstash configuration. So it really saved us a lot of time and a lot of hassle, because my scripts would invariably break every once in a while. So Logstash is the broker that takes the data from the network, puts it into Elasticsearch. And now you need a way to look at the data. So for visualization, we picked Kibana, which takes the data from Elasticsearch and then gives you the ability to pivot from the data, so you can chart it, you can search it a lot easier than just using the backend for Elasticsearch. I was also going to mention Moloch. Anybody heard of Moloch here? Anybody know what full packet capture is? Awesome. So Moloch is an open source program, or collection of programs that AOL launched, let's say 3 years ago, to listen in on the network and capture all of the packets going in and out of your network. And so we started using it. I put it in place at Devon about 3 years ago. Started off pretty small, developed it since then. It gives us all a really great ability to just go back in time for the past 2 weeks, look for all traffic, let's say to China, or look for all traffic to port 8080, but then also get all of the information from the packets to start analyzing it. In case you have an infection and you know the malware came in 2 weeks ago, you can still go back, get the malware, put it into VirusTotal, and see exactly what it does, so that you know how to clean up the machine.
So you have this running on your system full time?
Mm-hmm. Yeah. The Moloch box, or the Moloch cluster, is running on currently 10 servers. I have 2 servers that are capturing the packets, and then 8 Elasticsearch servers that are recording the metadata for the packets. And it's running at all time. It's indexing. Yes?
It's running all the time. Wouldn't that generate very large files very quickly?
You're right. Yes. I have about 16 terabytes of metadata and about 40-something terabytes of network capture data. Yes?
How long do you plan on keeping this data?
That's the awesome thing about Moloch. I can keep the metadata and the data for different times. So I can't keep the PCAPs for as long as I want to, because those are the most storage intensive. So I keep those for about 10 days. but then I keep the metadata for 6 months. So I have a record of transactions for about 6 months, even though I can only pull the stuff from the packets themselves for about 10 days. Yes?
How long does it take to analyze all that?
Do you mind rephrasing that?
Well, so you said you had 10 days. What specifically are you looking for, like alerts or red flags, or what exactly are you looking for, and how many people do you have doing this kind of thing?
I can answer part of that question. So we typically, let's say we get an alert, and we'll use the information from that alert. Like let's say it has an IP address on one. We know that the alert says we have this specific IP that's going out on port 80 to this other IP. And we can use Moloch to search for that specific packet or packets and then pull them down if they're recently, and if not, then we have the metadata to kind of go off of.
Okay.
Does that make sense?
Yeah.
So we're not analyzing this data real time. We just have it there as a network DVR. In case we need to go back, we can go and look at it. Which other?
In the event of an incident.
Yes. An event of an incident, and then the metadata comes in very, very handy to do some network analytics, if we ever get a chance to do so. It's fancy and we're not there yet. So, Moloch was the way we got started with Elasticsearch, because I put it in place, it was pretty easy. We realized we had 8 Elasticsearch servers that were busy, but they had a little bit of extra capacity. So, we just started putting data into it. First, I did the Python scripts, they worked okay. Then we did Logstash, which worked a lot better. So what are we collecting? As I said, we can't have an agent. We would like to have an agent, but we can't really have an agent to do all of this because it's very intensive. But a one-time script that runs on the host, it wouldn't be that bad. If I ruin the user experience on an infected host, I would get a lot less negative feedback than if I ruin the user experience on all 10,000 machines. And so we send in the script, and initially it was just a collection of WMI queries written in batch, just in Windows CMD. It would put them all into a file. We would somehow get the file from the machine and put it into Elasticsearch. It was really clunky. It wasn't very pretty. But here comes PowerShell. PowerShell is awesome. Who knows what PowerShell is?
What it is, never used it.
Have you used it? Okay, PowerShell is the new command interpreter from Microsoft.
Yeah.
Let's call it that.
Microsoft's response to Bash, I guess.
Yes, it is Microsoft's better and cooler Bash. As much as I am a Linux fanboy, PowerShell is just amazing because you can do some things in PowerShell that you can't do in any other of the command interpreters. So not only can you launch commands like ipconfig to see exactly what your IP address is, or run any of the WMI commands to to interrogate the registry and the WMI database for the host, you can use the .NET libraries. And so PowerShell is an interesting bastard child between a programming language and a scripting language. And we use it as both. We kept all of the WMI commands, which is really nice. But then we also added MD5 feature, which is very easy because all you have to do is go, read the file like you would in any programming language, and then MD5 it because .NET has that function. Which makes it the best thing about this is that you don't have to bring in 10 different executables to make this work. You just submit the script, you use the .NET libraries, you use what's on the host already. Attackers are doing this to great advantage, and so we started trying to do this on the defense side too. Instead of sending in 10 executables, we just have different calls from PowerShell. And now instead of actually recording everything into an XML file, we can just send them over the network via syslog as a JSON object to Elasticsearch via Logstash. So everything is quick, everything is instantaneous instead of having to wait 5, 10, 30 minutes to get everything parsed and then make sure there's no errors in there. So now I'll kill you with Visio. Here's how we actually use it. We have the SIM, we get an alert that, let's say, Chad's machine has been compromised and there's some antivirus alerts. then I'm mad at Chad.
Would be the first time.
And I say, let's figure out exactly what's going on. So from my computer, it's pretty easy. It's just right click or a command via the terminal, which is what Chad's going to show you. And I can either use our log system or our endpoint management system and send that script over to Chad's computer. The script runs on Chad's computer, and as it's gathering data, it's sending the data over to Logstash, which then parses it, puts it in Elasticsearch. By the time I record a little bit about the incident, it was Chad's computer and it's so-and-so malware, I can go into Kibana and start looking for my indicators of compromise. So what are we looking for? I kind of hinted at this before. Once you have a baseline of your network, you can start looking, or even of your host, you can start looking for weird-looking stuff. So we look at services, we look for processes. If you don't have admin on your endpoints, then it makes it very, very easy. Because if you see anything running from the user's folder, it's either not allowed or not installed by IT, or it's malicious. And so anything running from Chad's folder, from C users app data, C users Chad app data something, that's something to look at again, or to look at some more. Processes or services are very interesting there. Prefetch, those are stubs that Windows leaves on the hard drive every time it starts a program. And so if my alert from antivirus said that crypto.exe ran on Chad's computer, then I see in his prefetch that there is a crypto.exe in there. I know for sure that it ran and the antivirus didn't catch it before it ran, which then makes you take different steps to clean up the machine. If it didn't run, antivirus cleaned it up, there's no indications that it actually got compromised, you're just going to move on with your life. If it actually ran and there's indications that the malware was on the machine, then you have to do some serious incident response and some serious cleanup. So prefetch, startup items are also very interesting to look at because you can tell when the bad guys are establishing persistence. So you have a virus, you want the virus to keep running on the machine. As a bad guy, you convince the victim to double click on your executable. The executable runs. Not only does it start doing the evil things it wants to do, but it also puts a stub somewhere in the registry or somewhere on the hard drive to ensure that next time that the computer runs, the virus is going to run as well. So startup items then gives you, as the incident responder, as defender, gives you the visibility into what exactly starts over and over again. And again, you see something starting from application data, you know for sure that it's not something sponsored by IT, and it's something you need to look at again. I talked a little bit about MD5 signatures and how, because of PowerShell, we can take some MD5, and Chad's going to show you what we can do with those a little bit later. And then we took in a couple more data points, just the network information for the hosts, and then the software inventory on the host itself. Those are more for our ongoing telemetry than they are necessarily for incident response, but they prove useful sometimes. So now Chad can try a live demo.
All right. Let's see if we can get this to work. So I have 3 boxes, and it kind of represents that Visio diagram that Paul had up there earlier. We have an incident response box that's going to kind of take place of our SIM, where we currently deploy the scripts from. It's kind of hard to replicate a SIM, so we're just going to launch it from just calling it an IR box, just a workstation. And then from there, we also have a box that Paul built, and I believe he's going to share with you a little bit later on in the presentation that shows where you guys can grab this ISO and you can play with this. So it's basically Elasticsearch, Logstash, and Kibana already set up to go. All you have to do is log in and change some IPs around. You guys can play with this yourself. Uh-oh. So I think my IP address may have changed. No?
Network host only, maybe?
Shouldn't be. Sorry, I'm going to keep doing that. Tell them a funny joke, Paul.
I don't have any funny jokes, I'm sorry. But if you have questions, I'll be happy to answer questions when he's getting this set up.
How difficult was it to set up Logstash and Kibana and all of that?
It's not very difficult. There's a ton of tutorials on the internet about how to do it. How to do it in a test environment, kind of how I set this up. If you want to do it production grade, it's a little bit more difficult. You have to think about a few more things than this. But I'll get to you in a second, sorry. Because I didn't find a machine that did all three of them, that's why I made the ISO. Just so that if you want to play around with it, you can just download and start instead of spending the 15 minute to 2 hour time to get the ISO set up. Yes, sir.
So how effective is it compared to what you're doing before?
I'm sorry?
So how effective is ELK compared to what you're doing before?
ELK is great because it was easy to set up. So I can compare ELK maybe to Splunk. And it's about almost as good as Splunk. If I had my choice between them, I'd probably pick Splunk, but Splunk is expensive and costs money, especially to do it at scale. So we went with this. This has just been very, very, very interesting. Probably the best thing we got out of it is about 4 gigs of host telemetry, which then I can go back and do some data science kind of stuff to it and see if I can figure out some patterns. The process of running the script and getting the data back to us. You good to go?
I'm good.
Okay. The process of running the script and getting the data back to us has proven very cool. Because in the past, we'd get the antivirus alert and we'd kind of 50-50, well, we assume it's compromised because maybe it ran, so we're going to just reimage the machine. And reimaging a machine costs between $1,000 and $3,000, depending on, this is kind of funny money, but it's about as much as it costs in the enterprise, because you have IT person's time, you have the security person's time, you have the business guys or girls' time, and then you also have some downtime included in that. So if you take all of that into account at a reasonable rate, that's about $1,000. So we want to move away from reimaging machines, but we want to make sure that we're not running malware to our network. So having something like this is really helpful with it. Chad.
All right. So, and I think a few of you raised your hand and said you were familiar with PowerShell, right? So within PowerShell, you can create a profile. So whenever you launch it, you can have it automatically load pre-built functions. So what we did here was create this function called runIR, and it basically it takes a parameter called computer name, and it basically just invokes a specific command on the remote computer that you're passing to it, and tells it to go and download this PS1 file, which is another PowerShell script. So this is kind of a way we decided to deploy it so we can manage the PowerShell script essentially and not have to have it across a bunch of different IR boxes or whatever. So it's kind of a neat way to get the script to run on the box. And Paul showed you a little bit of that script earlier, and I'll just go into a little bit more detail here. The first part, we're just telling it where the server is, so it knows where to send the metadata that's collecting, the port. And then we grab the current logged in user and the host name of the box. And then we're defining a function here to send the data over TCP. And I'll scroll down a little bit more. And we have this set metadata function. And basically, for each one of these processes, we call set metadata, and we're passing different values to it, being the username, the host name that we collected up above, and then the type of metadata that we're collecting, like processes or startup or services and so on.
So we're doing this to provide a few points of correlation between these data points. Sorry. So we're doing all of the user information, we're doing all of the IP address information, so that whenever we search Kibana later, we can just search for the username and we'd have all of the metadata connected with the username, or all of the metadata connected with the IP address or the host name.
So we can go back in and just search by that, right? So we don't have to go through and try to compress it down to a certain time. We can go through a range of dates or months, if you will, and search for a specific host name or username and pull all the metadata for that box. for that user. So here's just one of the types of data. It's basically doing the for each loop using this get WMI object, which is really cool. There's lots of different things you can pull from the box, a lot more than what we're pulling here. So if you have a chance and want to play around, do some research on what kind of data you can pull, it's pretty interesting. You can do a lot of things. And next, I'm piping it to a select object and telling it, out of all the different properties that you can get from that command, I only want to see those 4 or 5 things. And then I'm passing it to the set metadata and adding the extra data to that array. And then here at the end, converting it to JSON, because that's what Logstash likes. And Elasticsearch is basically a index of a bunch of JSON documents. And then I'm just sending it over to the server. So what we're going to do now is run over to this other box here where I have downloaded a CryptoLocker sample. We just pulled something down off VirusTotal, and so I'm just going to run this.
Anybody familiar with CryptoLocker? What does CryptoLocker do?
Basically, it will encrypt some or all of your entire drive and basically hold it ransom. Had a bad running in with a cell phone version a while ago.
Yeah, I've been reading about.
It wasn't my phone.
I've been reading about they're seeing a big jump in crypto ransom malware on mobile phones. It's kind of interesting. All right, obviously, if you see this on your screen, you know you have something bad you're dealing with, right? So let's say you get a call from someone, maybe the help desk received a call, and then they've escalated to security department. And as an incident responder, your job is to verify that is actually on the box and figure out what we're dealing with. So I talked about before, I have this profile set up to run based on this command. So I'm just going to do run IR, computer name, and actually pass the value of the computer name and then hit enter. And it's going to prompt me for my credentials. And I'm just doing a TCP dump on the server, and now we can see the data coming across from the box. And it goes through all those different ones, like I said. MD5 is a little bit more time consuming. It loads a .NET library, and then it searches through directories on the computer where the user has capability of writing to, and basically takes a hash of any executable file, so an exe, DLL, and we could add others there, but I think that's all we're limiting to right now. So I think it's probably done. I'm going to jump back over to my IR box now and pull up Kibana.
So the biggest problem that I've seen currently with my image is that date and time sometimes get really skewed from the host OS. I didn't spend the time to figure it out because I just did the image in about I don't know, let's say 3 days. But yeah, sometimes they get skewed by a few hours.
Yeah. So we have some data here, and with this resolution, it's kind of hard to see it all on one screen. But we have several different dashboards where you can view the data that we've collected. And so right now I'm just searching by a wildcard. I'm not really filtering on anything. But as an incident responder, I'm going to try to go through things quickly, but not necessarily fast. So what I want to try to do is determine what results can I go through and not have to spend a lot of time, right? So I'm going to try to focus on things over here that have less items. And I think in this particular case, I'm going to just click on Startup. And, well, okay, I'll filter here. So I'm filtering on Startup, and it's only going to show me things that have startup in the system. So anybody see anything weird there?
Crypto 13.
Yeah.
I
So
don't know, that sidebar seems kind of sketchy.
It is.
all right. So here's the metadata we collected for startup, and specifically this particular startup item. You can see it's running out of app data, which is probably a little worrisome too, right? So I can pivot from this by taking this value here, copying it, going back up and pasting that in and turning that off. So now in our dashboard, I'm filtering by that executable, and we can see the different types of data that we have on that executable. So we already looked at startup. We see something in prefetch, so if I click on that and filter it down, there's our prefetch data. So that means we can verify that whatever that is, it's bad, that crypto 13, it did run, right? Let's turn that one off and look at MD5. So here's some of the most interesting part obviously is the hash, right? So there's a cool plugin you can download from VirusTotal. Allows you to select something, right click on it and check it within VirusTotal. So if I think that's a bad executable and I want to, again, just get that extra step of verification, pull this up and see what happens.
Up there it is.
Any other questions?
Good.
So VirusTotal actually keeps a record of known hashes for...
Yep.
VirusTotal is a genius thing that some guys did before Google, and now Google bought them, where it allows anybody in the world to upload executables, documents, anything to it. You get the file into VirusTotal, they run it against about 40 to 60, depending on the day, antivirus engines with current signatures, and then gives you back the response for it. It's good for you as the end user because you can immediately check against or antivirus engines you don't have. It's great for them because they can get a wonderful malware zoo without having to spend much money on downloading the executables. They just have to provide the service to you.
One thing to be cognizant of though with VirusTotal is you don't want to submit things that aren't commodity based. So like here they just submitted a hash and you can need a signature. You want to be careful about specific malware you submit to VirusTotal because the malware guys are also watching VirusTotal to see which versions of their malware have been identified. And if they wrote something specifically for your organization, they will know that it's now been found out and they can modify it on the fly too. So there's some other services you can use that don't submit the information publicly.
So it's a double-edged sword.
Yes.
Especially if you have people writing metamorphic code, it'd be very dangerous if your company's targeted by metamorphic code for this.
But
there's also the advantage of they're going to also submit their own code, right? So there's a service you can sign up for and get access to any file that's been submitted, and you can put in YAR rules and things like that to that hits on a specific malware that you're aware of or a certain key in the strings that you're looking for, and you can sign up for that service. Of course, you have to pay for it, but it may allow you to target malware before anyone else knows about it, and then obviously put those blocks in your network and your various security controls to protect yourself. Any other questions about what I showed you guys? So, all right, well, I'll hand it back over to Paul then.
all right. What else are we talking about? This I might show you or I might not. I don't know if I want to attempt to demo gods with this. So we have, yes.
So the big thing that I remember reading about CryptoLocker was that it didn't store the hash for the encryption on the device, so you couldn't decrypt it easily.
Mhm.
So if you guys are monitoring the entirety of the internet traffic, would you guys pick the hash out and decrypt the device, or would you just re-image it?
Just re-image it.
Just re-image it?
They do some serious cryptography. So,
Speaking of that, would you pause my VM?
yes. Oh, yeah.
Thank you.
Just in case it moves laterally, right?
Right. We are on their Wi-Fi.
On the Wi-Fi?
I'm pretty sure we'd hear Brad from here.
Yeah. Where's Brad? I can feel him coming here.
So yeah, we're very paranoid about CryptoLocker because not only do they do very good encryption algorithms, now they even target the network drives. And so then you can get into a very interesting situation where you have somebody with a lot of network access and all of your network drives are starting getting encrypted, and you can't unencrypt them unless you pay the money. Yeah.
That could be just devastating.
Yes, so every time we see crypto, we go into full alert mode.
Do you guys have like special quarantine procedures in place for that?
Unhook it.
Yeah.
Part of the server. Pull the plug.
Serious. We've had hardware damage from CryptoLocker. We've actually had it brick machines, like motherboards toast. Everything's toasted right into the chips. It's bad.
Yeah, so if it doesn't run as admin, and if we catch it in time, we have ways to isolate the machine from the network using the local firewall. And then we're developing ways to isolate it via our NAC system. So yeah, as soon as we see something that we think is a successful compromise, we immediately isolate it.
Okay.
Just in case. So the coolest thing with the best thing with Kibana, you can search, you can visualize the data, you can look for evil patterns. But what happens once you figure out a way to look for evil patterns? It would be really cool if you could actually take those processes that you do and turn them into a script, because our goal is to make ourselves obsolete and write scripts to do our job for us. So that's what I'm toying with right now. You have Elasticsearch, you visualize, you realize that things running, let's say, out of app data is evil, or you look at the MD5s, you submit them against VirusTotal, you look for a certain number of true positives. If you see 5 or more detections, it's probably a bad thing. You need to start cleaning up the machine. And so then I'm working with Python and IPython to just look at the data from Elasticsearch and just pull in all of the MD5s I have, let's say, for the past month. So, it's something that manually would take me forever to look for, but because I can script it, I can go back and look at, let's say, 4,000 entries and just have it do the job for me and do it in 2 days rather than me having to do it for a few weeks. So that's what I'm doing right now. I'm submitting the MD5 to VirusTotal into Team Camru. Team Camru also has a malware repository. It's not as extensive as VirusTotal, but they don't have the restrictions and or cost VirusTotal puts on you. And so I wrote some scripts to just send the data to them and see if the MD5 is bad. I'm not sending the file, I'm just sending the MD5. And so if they don't have it, I don't want the bad guys to know that I know about it. I'm just asking if those services, or if the file has been submitted by somebody else already. And then the other thing that we're looking at doing is to compare the MD5s with a set of known good signatures. So if I have some kind of configuration management in my network, I probably know what a clean Windows machine would look like, what executables need to be on it, what settings need to be on it. And so before I deploy it into production, before I send it off to the user to break it, I can check the processes running, I can check the MD5s, I can check kind of everything on the host, and I can call it the golden image. So I know what's running, I know what's normal. If I know what's running, I know what's normal, I put that into Elasticsearch. I can just have a process in the background, run every hour or so. Pick up my MD5s, pick up the processes, and compare it to the known good image. If it's known good, I don't have to worry about it. I can even mark it known good. If it's not, then I can give it a second look whenever I go back and look for my data.
You just have a search option running in the just always compare the this.
I haven't figured out a way to automate it like that, but I have scripts, or I'm working with scripts to go back and look at the data in Elasticsearch of that.
What's Elasticsearch written with?
Java. Like all good things in the world.
Java's fun though.
Yeah, so it's a derivative of one of the Hadoop derivative big data kind of thing. So it's Java, and I forget exactly the project. It's not Cassandra. Do you know?
I don't remember.
So it's a derivative of one of the Apache projects for big data. It's resource intensive. It doesn't do very well if you don't have at least, let's say, 30 gigs of RAM in the machines or in the servers. Depends on how much you want. So for the amount of data that we store in there, our 8 servers are a little bit underpowered. We have a 4-core processor and 16 gigs of RAM, and it's slow. We're moving towards it's having 120 gigs of RAM per server, and running a few nodes of Elasticsearch on that server. Because, and I'll go into this diatribe and I don't need to, but for database, especially for this kind of indexing database, you run into Lucene, yes. You run into performance issues depending on your RAM to disk ratio. So everything wants to be indexed into RAM because RAM is a lot quicker than hard drives are. The more RAM you have, the better it is. But because it's written in Java, if you go over 30 gigs of RAM per the Elasticsearch process, it starts crawling because there's inefficiencies in the code. Java. So, yes.
Oh, sorry.
Java. Fortunately, I don't have to look at the code. It just works. I was going to tell you guys how, if you want to play around with this, how you can do it. Initially, we used the Ubuntu for the image, but then I got lazy, and so I ended up using SUSE because it's very easy to just drag and drop packets into the image and to just publish it as a either VM or ISO. So if you want to play around with it, I'll give you the link in a bit. One way to get it from SUSE Studio. All you have to do to get started is download it, start it on VMware, change the root password, because that's the smart thing to do. You can add some sample data, and we even included some sample data in there in the opt folder. Add the Kibana dashboard, which is available on GitHub. And yeah, if you want to deploy the PowerShell script, you can change the address in there to make sure it talks to the right box. If not, you can just poke around Kibana. So
you have to do some tweaking with PS remoting as well, because by default, boxes on a domain. I mean, even if they're on a domain, I think you have to do some tweaking with GPO, but we'll have to turn on some PowerShell remoting features to be able to make the connection.
So maybe I should talk about what we've learned from it. You'll hear in your career the word silver bullet over and over again. It's a cute little marketing term, and it means absolutely nothing. Each year you have a different technology that comes up in the security space, and everybody is touting it as the thing that solves all of security problems. At one point it was intrusion detection, then it was intrusion prevention, then it was security incident event management system, then it was threat intelligence, then it was, what's this here? CASB, yes. Cloud security. Then some people might hear about automation and DevOps, and we think machine learning. No, that's next year. That's growing in the hype cycle.
Hi, for one, welcome to Robot Overlords.
It's happening this August. Or actually, next August. Mark your calendar.
Let's just start writing metamorphic coding. That sounds like fun.
So the more we kind of play around with this, the more we realize that actually DevOps, or being able to script a little bit, being able to program a little bit, is going to take you a lot farther as a security program than just buying new and more tools. Because if you can get the tools to talk to each other, if you can get the tools to interact a little bit, you'll get a lot more mileage out of all of the tools. But you have to learn scripting, and you have to learn programming, and you have to learn how the tools actually work on an API kind of level. In the future, so I have the script that works okay at getting the MD5. I haven't deployed it on a very operational kind of basis, so it's still a manual start for the script to get my results. Eventually I want to get it to automate and to just find the evil for me and in my database. I also want to be able to do some more interesting things, such as look for slightly misspelled processes that I might not catch by hand, look for weird looking prefetch, and for that I just need to write a code against the actual database, and I don't want to do that quite yet. Another thing that we're looking at is to use a host intrusion system, or to write some scripts to do host intrusion based on WMI code. I didn't ask this, but do you guys know what WMI is? Windows Management Instrumentation Interface?
Sure.
Microsoft developed this a while back as a way to manage all of your Windows hosts in your network. And so it's similar to what, like in a Linux network, you can do with SSH, to where you can see what commands are running, you can run commands, you can write things to registry, look for things from registry. Turns out, just like PowerShell, this is really useful for advanced attackers. At DEF CON, there was an interesting talk from the Mandiant guys about one of the advanced Chinese groups, instead of storing payload on disk as executables, they don't even bother with that. Sometimes they do it in registry. A lot of times they just write it as binary objects for WMI. And so then, most of the tools you have available to you, including our scripts here, are going to be pointless, because you can't really tell where the malware is. You can't MD5 an object, a binary object, somewhere that you don't have any stub of it on the disk. So they had some interesting ideas on how to do intrusion detection based on that, but that's still a bit out of our grasp for right now, both time and skill level. So that's all I have to say, or that's all we have to say. Here's our contact info, and I can give you the link to download the stuff, I think, in a little bit.
Thank our wives for being understanding.
There was, especially in the week before the IWS talk, we had a few late nights where we had to make sure everything was working.
Mine just texted me.
Take a picture, send it to her.
Yeah, take a picture, send it to her.
How'd you know we were talking about it?
See no golf clubs.
All right. If you have any more questions, I'll be happy to answer. I'll be happy to answer them if not.
How often is your system attacked?
All the time. It depends on what you.
How many times a day is somebody trying to get in your system?
All the time.
Every day.
Say to quote my dad, you plug it in, you get attacked.
It depends on what you mean by attack.
Trying to get information that they should not have.
By that,
Any kind of intrusion.
you know, by that definition, a port
I guess
scan
what I'm
is an
trying to
attack.
say is, do you
right?
ever have an easy day?
Yeah. Saturdays.
When you turn off the machine.
Yes, sir.
How do you, if you do deal with like an insider attack, like if somebody like inside was intentionally doing something?
It's not any different from an external attack, because most of the attacks now, they don't necessarily happen on the perimeter like you expect. They're not firewalls and things like that. We have most of those external vulnerabilities taken care of, because that's pretty much where you focus a lot of your efforts on initially when you're maturing your program. But they're usually on the inside. They usually have a credential. They're usually pivoting just like a normal user would. There's obviously malware that they're going to drop and things like that. But
Okay.
and then there's DLP solutions too, right?
Everything I hear from the news, if you know is accurate, is most of the attacks are from inside.
You use your computer or something like that, it strays from your baseline.
I get to draw after all. Yes. So, I'll do a little Visio for everybody. So that's your corporate network. Our initial, or our security posture in the past has been, you know, you're going to put a firewall here, you're going to put an intrusion detection here, system here, you're going to have a DMZ somewhere here. That's going to have your public presence. And we're going to defend, like our life depends on it, right here. Right. This is where we need to defend, because this is where your public IP is. And that's nice and it's cute, but that's not how it works anymore. Because So you get this really awesome Apache exploit that only you know about, and you launch it against my Apache server in the DMZ, and you'll get root on there, and you're good to go, right? And then you have to go from DMZ to Corp, and you have some more awesome tools that you can use. It might work once in 20 times or something like that. An easier way to get into my network?
User?
Phishing.
Against wireless.
Lock up and plug something in.
Easier than that. Phishing. Metrics for phishing. 1 in 7 phishing emails is successful. Try that with any of your fancy exploits. So you send a link to 7 people in the company, and it's pretty easy to get 7 emails into any company you want to get into. You send a link to 7 people, and one of them is going to click on it. And then you're there. So you can do all this fancy stuff, but you just send an email, and somebody's going to click on the email, and then you're here. And then if you have a open network inside the corporation you're attacking, it's very easy to pivot around. Because if they click on the email, they get the malware on the disk. You have credentials. You have a good hash. You can just pivot around at will. So, what I'm trying to say is, outsider or insider attack, the most successful ways to do it, and the way the advanced adversaries are doing, they always aim for the meat where they always want to attack us.
Security awareness.
So, security awareness is probably one of the more security awareness is a security tool out of which you get the most mileage. Probably spending $100,000 on security awareness versus $100,000 on an IPS system, you're going to get a lot more out of security awareness.
Do you guys offer any type of internships or anything like that?
Yes and no. We had a little program that we were running, and now we had to take a little break from it. But if you want to apply for an internship, go ahead and send me an email. We might have something for maybe not next year, but the year after.
I get heads up every time there's one. So I have a family member.
So, thank you very much.
Silly question.
Cool, thank
Do
you.
you guys secure the entire Devon network or just the one downtown?
Hey, there's this.
The entire Devon network.
Okay.
Because all those conferences are like tons of people. Speaking of which, I have to call them.
We're good. I don't know how to stop the recording, but I guess we'll figure that out. You know, Sean?
I do have a question. Can you submit arrays into the Elasticsearch?
Yeah. Anything for whatever JSON. Why would you do arrays?
What? So your problem is submitting and is automatically submitting stuff into the Elasticsearch tool. Is that what you're trying to do? When you're limiting data for like the golden box, is you're automatically submitting it? Is that where your problem is? Or
No.
Well, if you put everything into, say, an array list, single item, this is what you need, and then submit. If only these items aren't there, why don't you, only these items aren't there, then it's not the golden